of you had already know that mathematics has an application in different fields, such as physics, chemistry, computer, economics, business, finance, geosciences, and other fields. Now, do you know that mathematics has an important application in political science? Yes, and that's what we're going to discuss today, the mathematics of voting.
Good day everyone, I'm Karen F. Norte, Tribe 4, Space Pioneer. For today's lesson is all about the mathematics of voting, plurality method. Objectives: define plurality method and apply plurality method. What is voting? Voting sometimes more involved than just electing whoever gets the most votes. There are several methods of determining a winner. A certain method for selecting a winner may be more appropriate based upon the type of election. For example, the method of electing a president fairly might be different than a group of friends fairly deciding what movie to watch. Let's consider an example to see why issues can arise when selecting winners of election. Here are the examples. Consider the following result from student body president. Candidates, name of first place votes. Candidate A have 80, candidate B have 98, candidate C have 94, and candidate D has 76 and E 102. There are total of 450. Notice the candidate has a majority more than 50%. Now, let's assume the voters rank the candidate from their first choice through their fifth choice. Consider the following result from student body president. Here the example. In this table, notice except the 102 who vote for E, most voters really seem to dislike the candidate because the candidate is ranked 5th by everyone else. Also, everyone that didn't vote first rank, second rank, B is the disliked by anyone should be win. This leads to an interesting discussion about voting theory and voting methods. What is plurality method? In this method, the voice with the most first preference vote is declared the winner. Ties are possible and will have to settle through some sort of runoff vote. This method, sometimes mistakenly called the majority method or majority rules, but is not necessary for a choice to have gained a majority of votes or win. A majority is 50%. It is possible for a winner to have a plurality without having a majority. And also, this is the definition of insincere voting. Insincere voting situation when there are more than one candidate that share somewhat similar point of view can lead to insincere voting. Insincere voting is when a person casts a ballot counter to their actual preference for strategic purposes. In this case above, the Democratic leadership might realize that encourage voters to vote, not wanting to see their party lose in the election. As happened in the scenario above, they effectively voting against. Thank you.
Hi, I'm Kate Pelinciok from Tribe for Space Pioneer. Now we will discuss the plurality with elimination method. So, what is plurality with elimination method? A very simple voting method is to declare the candidates with the most votes the winner. The fairness of these outcomes is clear if the winner has won majority of the votes, meaning more than 50%. However, in races involving more than two candidates, one may have more votes and any of the others but still fall short for the 50%. Their hold for majority. This is how we define plurality. Meron pa ako dito ng example para sa plurality with elimination. I-identify natin ang winner using the plurality and elimination. Meron po tayo dito ng tatlong choices, which is B is for volleyball, basketball, V is for volleyball, and T is for tennis. Paano nga ba natin makuha ang majority? Using the formula of majority approximated total majority over 2. So, paano nga ba natin makuha ang total of majority? I-add natin yung 17, 3, 16, 9, 25, at 19. Is equal of 89 over 2. So, 89 divided 2 is equal of 44.5. Since tayo ay approximated, i-round off natin siya into nearest 1. So, magiging 45 po siya. Paghahanapin naman po natin ng plurality, it's either na sumakto siya sa 45 or malapit po siya. So, hanapin na po natin yung vote ng basketball, volleyball, at tennis. Si basketball rather, meron po siyang 17 na vote. At sa kabila naman, meron siyang 9 na vote. So, 17 plus 9 is equal to 26. And si volleyball naman po, meron siyang 3 votes and 25 votes. Kaya magiging 28 votes lahat. Si tennis naman is 16 and 19. Kaya magiging 35. Kaya sa plurality with elimination, meron ma-eliminate. Yung pinakamababang votes, siya yung ma-eliminate. So, si basketball ay ma-eliminate. Kaya tatanggalin na po natin lahat ng B sa choices. After po nun, is eliminated na nga po si B, which is yung basketball. Yung nasa baba po ng B, ay sa kanya po mapupunta yung vote. Kaya po yung volleyball, magkakaroon po siya ng 17, which is 28 plus 17 is equal to 45. And si tennis naman po ay 35. Yung nasa baba po ni B is T, so it means 35 plus 9 is equal 44. So, sa dalawa po, yung pinakamataas po sa kanila is si volleyball. Na-hit na natin si 45. So, siya ang i-declare natin na winner. We can conclude that volleyball is the favorite sports with 45 votes.
Good day everyone, I'm Lizelle A. Collado from Tribe Number 4 Space Pioneer. The topic we'll discuss today is all about instant runoff voting. So what is instant runoff voting? Instant runoff voting, the choice with the least first place voters is then eliminated to the voter's next choice. So, ibig sabihin yung may pinakamababang votes, siya yung may eliminate or matatanggal. Diba? Kung sino may pinakamababang points, siya yung matatanggal. Okay, here's the sample question. Consider the preference schedule below in which a company advertising team is voting on 5 different advertising slogans called A, B, C, D, E. Here for simplicity, find the winner using instant run of voting. So, hahanapin natin siya gamit ang instant run of voting. So, first choice, meron siyang B, C, B, D, B, E. Sa first choice, may pinakamababang votes is si letter E. So, ibig sabihin, si letter E is cross out na natin. Matatanggal na siya. Tatanggalin na natin siya. Yan. Pinag-cross out na natin lahat ng letter E na nakita natin kanina kasi eliminate na siya, tanggal na siya. So, yung score ni letter E is mapupunta kay letter A. So, ibig sabihin, sa letter A is lowest na din yung score niya. So, ibig sabihin, matatanggal na din siya. Tanggalin na natin. Ayan. So, ngayon, sino yung may pinakamababang score? Diba si letter C kasi may 4 na lang. Kasi si B mayroon 9. 3 plus 4 plus 2 equals 9. 7. Tapos si letter D naman is equals 7. Diba? Kasi 6 plus 1 equals 7. Si C, 4 na lang yung points niya kaya siya yung matatanggal. Eliminate si C, tanggalin na siya. Sunod, sino kaya ang mananalo? Si letter B ba? Or si letter D? Let's find out. Sa letter D, meron siya pa ring 9 points. But, the letter D is meron 11 points. Bakit? Kasi si B, 3 plus 4 plus 2 equals 9. Sa letter D, meron siyang 4 plus 6 plus 1 equals 11. So, ibig sabihin, si D ang nanalo. Sa letter D ang winner. Thank you for listening. I hope you understand the topic. And thank you.
Good day, everyone. Welcome to our lesson on Borda count method of voting. Borda count is voting method named after Jean Charles de Borda, who developed the system in 1770. In this lesson, voters rank all the candidates as first choice, second choice, third choice, and so on. So if there are k numbers of candidates, each candidate will receive k points for every first choice vote, k is equal to 1 point for every second choice vote, k is equal to 2 points for every third choice vote, and so on. So if there are 4 candidates, 4 points for every first choice vote, 3 points for every second choice vote, 2 points for every third choice vote, and 1 point for every fourth choice vote. And if there are 5 candidates, 5 points for every first choice vote, 4 points for every second choice vote, 3 points for every third choice vote, and 2 points for every fourth choice vote, and 1 point for every fifth choice vote. And the candidate with the most number of points wins. So, applying the Borda count method in this example, A has been the first choice 370 times, A has been the second choice 305 times, A has been the third choice 325 times, B has been the first choice 320 times, B has been the second choice 388 times, B has been the third choice 292 times, C has been the first choice 310 times, C has been the second choice 307 times, and C has been the third choice 383 times. So, ang ginawa lang natin dito is inad lang natin siya based sa vote na nakuha nila na makikita natin sa taas. So, katulad ng nasa first choice, A is 168 and 202. So, inad lang natin siya kaya siya naging 370. Since there are 3 candidates or 3 choices, the first choice will receive 3 points each, the second choice will receive 2 points each, and the third choice will receive 1 point each. And since it indicates in this preference table, A here has been voted 370 times as the first choice, then all we have to do is to multiply this by 3. It has been voted 305 times as the second choice, so we have to multiply this by 2. And it has been voted 325 times as the third choice, so we have to multiply this by 1. So ang gagawin lang natin dito is i-multiply natin siya based dun sa points na nakuha nila. Similarly, we have to multiply the same values with candidates B and C. And after getting the product, all we have to do is to get the total number of points. And since it is clear here that A has the most number of points, then using the Borda count method, A or Amanpulo wins. Now, instead of 1 point and every last choice vote, you will also use 0 for every last choice vote and you will get the same result. So instead of 4, 3, 2, 1, you may also use 3, 2, 1, and 0. And instead of 5, 4, 3, 2, 1, you may also use 4, 3, 2, 1, and 0, and you may get the same result. The Border count method is currently used in some modified forms, like in the island nation of Kiribati. Regardless of the number of candidates, voters rank only for 4 candidates that they prefer. That's all, thank you.
Space Pioneer. For today's lesson is about pairwise comparison method. What is pairwise comparison method? Pairwise comparison is a method of voting or decision making that is based on determining the winner between every possible pair of candidates. Pairwise comparison, also known as Coupland's method, is a form of preferential voting because voters submit a ranking of candidates based on preference, not a single choice. How do you explain pairwise comparison method? The method of pairwise comparison involves voter ranking their preference for different candidates. Based on all rankings, the number of votes who prefer one candidate versus another can be determined. The overall winner will be the candidate who is preferred by the greatest number of voters in this head-to-head comparison. This is an example of pairwise comparison method. B stands for basketball, V stands for volleyball, and T stands for tennis. In the pairwise comparison method, we have a formula of pairs. N times of quantity minus 1 divided by 2, wherein N is the number of choices. So, in this case, we have 3 choices. We have 3 is substitute 3 times 3 minus 1 divided by 2. So, we have 3 using PEMDAS. 3 minus 1 equal to 2 divided by 2. Mauna munang mag-multiply bago mag-divide. 3 times 2 equals 6 divided by 2, which is 3. There mean meron tayong 3 pairs. Since meron tayong basketball, volleyball, and tennis, magagawa tayo ng pairs. Basketball and volleyball, volleyball and tennis, basketball and tennis. Yan yung ating tatlong pairs na hahanapin ang numbers of voters. Ang rule ng ating pairwise comparison, kung aling letter ang nauuna between them, sa kanya mapupunta ang number of voters. And then we add the pair at kung sinong mataas sa kanya, mapupunta ang puntos. Tayo ng tally sheet kasi dito tayo magbe-base kung sino ang mananalo. So, in the pair basketball, we have 42 and the volleyball, we have 47. The winner is volleyball, kaya sa kanya ang unang puntos. And in the pair volleyball and tennis, the winner is volleyball again, and also we have a 2 points in tally. And the last pair, basketball, we have 51, and tennis, we have 38. So the winner of this is pair of basketball. So we have 1 point in basketball in the tally. So I conclude volleyball is the favorite sport with 2 votes.
In the previous video, we learned about the contribution of mathematics in political science, that is voting. Now, in this next video, we will learn about the contribution of mathematics in political science by the way of apportionment.
Hi, I'm Jubel C. Falmiano from Tribe 4 Space Pioneer. Now, we will discuss about the apportionment Hamilton's method. Objectives: define Hamilton's method and apply Hamilton's method. What is apportionment? Apportionment is a method of distributing a few items of proportionally into several groups based on a group population sizes. This method is based on standard divisor and standard quota of the population. These are the formula of Hamilton's method. SD is equal to P over A. SD stands for standard divisor, P stand for total of population, and A stand for required of allocation of the number of items to be distributed among the group. And SQ is equal to G divide SD. SQ stand for standard quota, and G stand for the size of the group. SD is a standard divisor. The standard quota is the whole number part of quotient of population divided by the standard quota. We have two types of quota, the lower quota and the upper quota. Lower quota is a standard quota rounded down to a whole number. Upper quota is the standard quota rounded up to the next whole number. Hamilton's method. Alexander Hamilton proposed the method that now bears his name. His method was approved by the Congress in 1791, but was vetoed by the President Washington. It was adopted in 1852 and used through 1911. Since he was interested in the question of congressional representation, we will use the language of state and representative. Hamilton's method provides a procedure to determine how many representatives each state should receive. This is the steps on how to solve a Hamilton's method. Step 1. How many people each representative should represent? Do this by dividing the total number of representatives. This answer is called standard divisor or divisor. Step 2. Divide each state's population by the divisor to determine how many representatives it should have. Record this answer to several decimal places. This answer is called quota. And step 3. Cut of all the decimal parts of all the quotas, but don't forget what the decimal were. These are called lower quota. Then, we add the lower quotas. This sum will always be less than or equal to the total number of representatives. Step 4. Assuming that the total from step 3 was less than to the total number of representatives, assign the remaining representatives one each to the state whose decimal parts of the quotas were largest until the desired total is reached. But take note, make sure that each state ends up with the least one representative. Now, we will try to solve using Hamilton's method. Example: determine a country with 5 states and 50 seats in Congress and population distributed as in the table below. State 1 has 106,567. State 2 has 83,027 population. State 3 has 23,467 population. State 4 has 76,873 population, and State 5 has 45,766 population with a total of 335,700. To find the divisor so that we will find the quota, we need to use the first formula, which is SD is equal to P divided by A. P is the total of population, which is 335,700, and A is the total of seats, which is the 50. 335,700 divided by 50 is equal to 7,114. Now find the quota. To find the quota, we will take all the population and divide it with 7,114. So, for the state 1, 106,567 divide 7,114 is equal to 14.9798. State 2 is 83,027 divided by 7,114 is equal to 11.6709. For the state 3, is 23,467 divided by 7,114 is equal to 3.2987. And for the state 4, 76,873 divided by 7,114 is equal to 10.8058. And for the state 5, 45,766 divide 7,114 is equal to 6.4332. And to find the initial, we will remove the decimal part of the quota. For the state 1, we will get the 14, and for the state 2, we will get the 11, and for the state 3, we will get the 3, and state 4, we will get the 10, and for the state 5, we will get the 6. And we will total it. We have a total of 44, but the total of seats is 50. Since the state 1 has the big amount of decimal part, state 1 received the another 6 seats, so total of 20. So, these are the finals. State 1 has 20, State 2 has 11, and State 3 has 3, and State 4 has 10, and State 5 has 6, with a total of 50 seats. Thank you for watching. I hope that you learn more about Hamilton's method from me. Thank you for watching.
What is Jefferson's method? Jefferson's method divides all population by a modified divisor and then rounds the result down to the lower quota. Sometimes, the total number of seats will be too large, and other times, it will be too small. We keep guessing modified divisors until the method assigns the correct total number of seats. Likewise, the Jefferson method avoids the problem of an apportionment resulting in a surplus or a deficit of house seats using a divisor that will result in the correct number of seats being apportioned. So what does this necessarily mean? So first, you are just going to divide all population by the modified divisor. So how can you do that? So in order to find the modified divisor, you are just going first to add all the population and then divide it by the total number of seats that is available in the House of Representatives. So say the total number of population is 1,000 and the total seats that is available is 10. So 1,000 divided by 10, so that it will be 100. So 100 now will be our modified divisor. Here are the 6 steps to follow in Jefferson's method. Number 1, find the standard divisor. So the standard divisor now will be total number of population divided by the number of seats. Number 2, pick a modified divisor that is represented by small letter d, that is slightly less than the standard divisor. Number 3, divide each state population by the modified divisor to get its modified quota. Number 4, round each modified quota down to its lower quota. 5, find the sum of the lower quotas. And number 6, if the sum is the same as the number of seats to be apportioned, then you are done. If the sum is too large, pick a new modified divisor that is larger than letter D, or our standard divisor. Now, if the sum is too small, pick a new modified divisor that is smaller than D. Then repeat steps 3 through 6 until the correct number of seats apportioned. Now, let's take a look at this example. So, supposedly, if a country had 4 states and a 20 seats House of Representatives are available. So, dito meron tayong state A, B, C, and D. So, 4 na state. And so, kada state ay mayroong population. Okay? So, state A has 2,560. State B has 3,315. State C has 995, and State D had 5,012. So, para makuha natin yung standard divisor, kailangan lang natin i-add yung total number of population from state A to B. So that will be 2,560 plus 3,315 plus 995 plus 5,012. So state A to B, that will be equal to 11,882. So na-total na natin ang population. Now, what we are going to do? So there are 20 seats na available. So kaya 11,882 will be divided into 20. At makukuha na natin ang modified divisor na 594.1. At si 594.1 ang i-divide natin sa kada population ng isang state. So take a look at the quotient na nakuha natin in each state. So in state A, 2,560 divided by the modified divisor, 594.1, that will be 4.31. Now, state B, 3,315 divided by 594.1, that was 5.58. Next will be state C, which has 995 divided by 594.1, that will become 1.67. So state D, 5,012 divided by 594.1, that was 8.44. So ano yung next na ginawa doon sa seats apportion? So ang sinasabi po natin na lower quota doon sa nauna ay makikita natin dito. So, kung sa numbers, di ba, we are thought of rounding off the numbers into its nearest ones, tens, or hundreds. Pero dito, sa Jefferson's method, hindi tayo kailangang mag-round off kahit po may decimal. So, ang kailangan natin na whole number ay yung mas mababa doon sa counted na decimal or doon sa quotient. So, take a look at number letter A, sa state A. So, ang quotient na po ay 4.31. So, ang lower quota ng 4.31 will be 4. So, that will be the seat apportion for state A. So, state B naman, 5.58. So, imbis na i-round off sa 6, ang lower quota ay 5, naging 5. So, sa state C naman, 1.67. Kung i-round off sana, that will be 2. Pero nasa lower quota nga tayo, that will be 1 lang po ang total. And, also sa state B, 5,012, ang quotient niya po is 8.44. The seats apportion will be 8. So, ano nang gagawin natin dito sa seats apportion? So, yung seat apportion ngayon ay i-add natin. So, kung yung seat apportion po ay mag-total ng 20, which is the available seats, then, okay na, we are done. So, 4 plus 5 plus 1 plus 8, that would be total of 18 seats. So, meron tayong 2 surplus. Ibig sabihin, meron tayong dalawang kulang. So, 18. So, what we are going to do? So, since meron tayong kulang na dalawa out of the 20 seats na available, ang seats apportioned lang ay 18 gamit ang 594.1 na modified divisor. What we're going to do now is to lower the modified divisor. So, tinry natin, nababaan si modified divisor from 594.1, ibinaba natin to 550. Meaning, si 550 na po yung i-divide natin doon sa lahat ng population sa kada states. So, take a look sa A. So, 2,560 divided by 550, that will be 4.65. Sa B naman, we have 6.03. Sa letter C naman, we have 1.81. Sa letter D, we have 9.11. So, titingnan natin if the lower quota pa rin ang pagbabasihan. If the lower quota ay magiging akma and exact doon sa seats apportion. So, take a look. So, state A, 4.65, that will be lower quota kay 4. Next, state B, 6.03, that the lower quota is 6. State C naman, we have 1.81, so we have a lower quota of 1. And state D, we have 9.11, a lower quota of 9. So, let's add the seats apportion. 4 plus 6 plus 1 plus 9 from A, B, C, D respectively. And now we get 20 total seats in the House of Representatives. So what does this imply? This implies that when we lower the quota or the divisor to 550, we can get an exact apportionment to the seats on House of Representatives. So that ganun lang po kadali yung steps in Jefferson method. Pag hindi gumana yung unang modified divisor, so kailangan lang natin mag-guess ng modified divisor in order for us to arrive at the exact apportionment ng seats sa House of Representatives.
I am Maria Jessa from Tribes for Space Pioneer. We will discuss about Adams' method. This method is similar to Jefferson's method, but this time, upper quota is applied. Upper quota ang hahanapin natin. Get standard divisor 17.5, 6.86 up to 4.4. So, kapag sinabing upper quota, look at whole number, mag-plus ka lang ng isa, may decimal value dito. 6.86 plus 1 equals 7. Ito naman sa 5.14 will become 6. It doesn't matter kung anong decimal value, as long as hindi siya 0. So, dito may decimal siya, so 7.71 equals 8. Yung 4.46 magiging 5, yung 11.43 magiging 12, at yung 4 dito magiging 5 naman. At kapag inad natin yan, the answer is 43. At alam naman natin na ang kailangan nating i-allocate sa final apportionment ay 40 lang. Dapat ang total. So it means we need modified standard divisor, at this time dapat mas mataas naman sa given na SD, kasi kapag sa Jefferson's kasi ang dapat gamitin mas mababa sa SD. This time yung mas mataas naman, kasi kapag tumaas ng unti-unti yung value dito from 17.5, lumiliit yung total dito. As I found out, yung MSD na pwede natin gamitin ay 19.25. Of course, possible na tumama sa 19.24 or 19.23. So, it's up to you to try it. So, ako sa 19.25, I found it very convenient to divide it. 120 i-divide sa 19.25 equals 6.23. 90 divide 19.25 equals 4.68. 135 divided 9.25 equals 7.01. 78 divide 19.25 equals 4.0. 200 divide 19.25 equals 10.39. 77 divide 19.25 equals 4. So, stop tayo dyan. 6.23 equals 7. 4.68 equals 5. 7.01 equals 8. 4.05 equals 5. 10.39 equals 11. 4.4 is 4 lang talaga siya. So, kapag inad natin yan, the answer is 40. Siyempre, sa final apportionment, gagayahin lang natin yung modification na ginawa natin. Yung final apportionment is 40.
Hi everyone, our topic for today is Webster method. What is Webster method? Webster method, also called the Saint Log method or the major fraction method, is a method for allocating seat in a parliament among federal states or among parties in a party list proportional representation system. The method was first described in 1832 by the American statesman and Senator Daniel Webster. It also modified version of the Hamilton-Vinton method after the state population are divided by the divisor. Those with quotient that have fraction of 0.5 or above are awarded an extra seat. States with a quotient with a fraction below 0.5 have their fraction dropped. When was Webster method? Daniel Webster, on 1782 to 1852, proposed a method similar to Jefferson's in 1832. It was adopted by the Congress in 1842, but replaced by the Hamilton's method in 1852. It was then adopted again in 1901. The difference is that Webster's rounds the quotas to the nearest whole number rather than dropping the decimal part. There are 4 steps in Webster's method. 1. Determine how many people each representative should represent. Do this by dividing the total population of all the states by the total number of representatives. This answer is called the standard divisor. Divide Divide each state population by the divisor to determine how many representatives it should have. Record this answer to several decimal places. This answer is called the quota. Third, round all the quotas to the nearest whole number, but don't forget what's the decimal word. Add up the remaining whole numbers. And last, if the total from step 3 was less than the total number of representatives, reduce the divisor and recalculate the quota and allocation. If the total from that step 3 was larger than the total number of representatives, increase the divisor and recalculate the quota and allocation. Continue doing this until the total in step 3 is equal to the total number of representatives. The divisor we end up using is called the modified divisor or adjusted divisor. Here are examples. Delaware with an initial divisor of 21,900.82,927. With the country of Kent, Newcastle, Sussex, the population are 166,310, 538,479, 197,145, with a total of 897,934. To get the quota, you just need to divide the population of the country 166 divide 310 to the initial divisor of 21,900.82,927. Then do the rest to get the final quota. Then to get the initial, you just need to look for the quota. Example is 74,111. 74,004 is less than 5. You just need Then, to get the initial, if the second numbers are greater than 5, you just need to add 1. If like the quota of 74,111, 74,111, just need to stay it's 7. Like it's 74,111, it stays 7. 24,500, 5,872 stays with it's add 1, so 25. And 90,017 stays 9. So these are the final initial 7, 25, and 9. To get the final, you just need to copy the initial. So here are the final 7, 25, 9, 41 with a total of 897,934 with the initial divisor of 21,900.82,927. That's all for today.
Good day, everyone! Our topic for today is all about the Huntington Hill method. What is Huntington Hill method? Huntington Hill method is similar to Webster method but attempts to minimize the percent differences of how many people each representative will represent. These are the example of how are we going to use the Huntington Hill method. Using Huntington Hill method, determine the apportionment of the total seats, which is 20 seats. The first step is to find the population. We must find the sum of the population, so the answer is 11,882 divided by to the total number of seats is 20, so that the answer is 594.1. And to find the quota, we must divide the population in the standard divisor. So that 2,560 divided by 594.1, which is the standard, the answer is 4.31, same as you can do to the remaining states. And to find the lower quota, remove the decimal points of the quota, which is 4, 5, 1, 8. For the upper quota, you must add plus 1 for the lower quota, which is the answer is 4, 6, 2, 9. To find the geometric mean, you must find the square root of the product of the lower quota and upper quota. For state A, the geometric means of the quota is the square root of 4 times 5 is equals to 20. The square root of 20 is 4.47. State B, 5 times 6 is equals to 30. The square root of 30 is 5.48. State C, 1 times 2 is equals to 2. The square root of 2 is 1.41. State D, 8 times 9 is equals to 72. The square root of 72 is 8.49. To find the final allocation, we must compare the quota and the geometric mean. If the quota is larger, we must round up. If geometric mean is larger, we must round down. This is now to determine state A. The geometric mean is larger. State B, the quota is larger. C, the quota is larger. D, the quota is larger. So that the initial allocation is 4, 6, 2, 8. We need to add this, so the answer is 26. This is the exactly final allocation of Huntington-Hill method of apportionment.
Hello everyone, I'm Christine B. Ramos from Tribe 4 Space Pioneer. My topic for today is about quota criterion. Before we start, here is the objectives that we'll be discussing in this topic, quota criterion. The first one is what is quota criterion? And the last one, what are the methods satisfies and violates the quota criterion? So, what is quota criterion? Quota criterion refers to the number of allocations given to a subset of a population is the standard quota or one more than the standard quota. Ang quota criterion daw ay ang bilang ng mga alokasyon na ibinigay sa isang subset ng isang populasyon ay ang karaniwang quota o higit pa ng isa kaysa sa karaniwang quota. What are the methods satisfies and violates the quota criterion? Hamilton method always satisfies the quota criterion. The way the modified standard divisor is chosen, it is possible that both Jefferson and Webster may violate this quota criterion. Huntington-Hill method may also violate quota criterion. Dito sa quota criterion, nasasatisfy natin ng mabilis pag ginagamit natin yung Hamilton method. At yung Jefferson at Webster naman ay pwedeng ma-violate niya ang tinatawag na quota criterion or yung tamang allocation. Kung quota criterion ang pag-uusapan o yung probability na mas tama yung pag-allocate natin base sa number of population or number of samples, mas okay talaga na gamitin ang Hamilton method. Saka, yung Jefferson at Webster naman ay pwedeng ma-violate niya ang tinatawag na quota criterion. Tapos, yung Huntington-Hill naman, pwede niya din ma-violate ang quota criterion.
Hi, my name is Veronica Kate P. Redondo from Tribe 4 Space Pioneer. Now we will discuss about the Alabama paradox. Objectives: explain the Alabama paradox. Give an example of the Alabama paradox. The Alabama paradox was the first of the apportionment paradoxes to be discovered at the U.S. House of Representatives in constitutionally required to allocate seats based on the population counts which are required every 10 years after census. In general terms, the Alabama paradox refers to any apportionment situation where increasing the total number of items would decrease one of the shares. Here is we have 3 states in 7 seat and 8 seat. This is the divisor of 7 seat. 14 divided 7 is equal to 2. And same in seat 8, 14 divided 8 is equal to 1.75. As you can see, in my example table, this is the 3 states A, B, and C. But state C share decreased 2 to 1 with the added seat. This is the population, quota, initial, also called the lower quota, and the final number of seats. The population of the state A is 5, and state B is 4, and state C is 2. The population will divided into the divisor, and the fraction is 2.5. And same at the state B and C will divide the divisor. The quota of state A is 2.5 and the state B is 2. And the quota of state C is 1. In the initial, I round off the 2.5 to 3 in state A. And I copy the number of state B and C. As you can see, I add 1 to the state C, and now in final computation, the state A has 3 and the state B and C has 2, and it equals to the 7th seat. In seat 8, same as the procedure of seat 7. But in the initial, I added 1 to the state A, B, and I decreased 1, so the final number is 4 in seat A and B, C is 0, and it is equal to 8. That's the Alabama paradox.
Population paradox. The population paradox is a counterintuitive result of some procedures for apportionment when two states have population increasing at different rates. A small state with a rapid growth can lose a legislative seat to a big state with a slower growth. The paradox arises because of rounding in the procedure for dividing the seats. Here are examples. A small country has 24 seats in Congress, divided among the states according to their respective population. The table shows population after a 2000 and a 2010 census. For Hamilton's method, apportion the seat. Population 2000 and population 2010. In Des A, we have 5,300 and Des B, 9,900, Des C, 22,400. The total of population in 2000 is 37,600 and the total of population in 2010, 45,000. A small country has 24 seats in Congress, divided among the states according to their respective population. The table shows population after 2000 and a 2010 census. The divisor is 1,566.667. Des A will have 5,300 divided by the divisor 1,566.667 is equal to 3.383, and the Des B 9,900 divided by 1,566.667 is equal to 6.319, and Des C 22,400 divided by 1,566.667 is equal to 14.298, and the total of population in 2000 is 37,600, and the total of quota is 24, and the total initial 23, and the final is 24. A small country has 24 seats in Congress, divided among the states according to their respective population. The table shows population after 2000 and a 2010 census. 45,000 over 24 is equal 1,875. In Des A, 6,800 divided by the divisor is equal to 3.627. The total of population in 2010 is 45,000 and the total of quota 24. The initial is 22 and final 24. The population paradox has occurred. Notice, Des A has the largest population growth but lost a seat.
Hi, my name is Jana Miribilla from Tribe 4 Space Pioneer, BSED1J, the new states paradox. If a new states paradox is added as well as a proportional number of a new seats, it seems logical that the number of seats of existing states will not change. This is not always the case, and adding a new state with its fair shares of seats can affect the number of seats apportioned to other seats. When a state gains or loses a seat, in this situation, this is called the new states paradox. The new states paradox was discovered in 1907 when Oklahoma became a state. Because Oklahoma became a state, the House of Representatives had 386 seats, comparing Oklahoma's population to other states. It was clear that Oklahoma should have 5 seats. As a result, the House size was increased by 5 to 391 seats. The intent was to leave the number of seats unchanged for the other states. However, when the 391 seats were apportioned, Maine gained a seat and New York lost a seat. Maine went from 3 seats to 4 seats and New York went from 38 seats to 37 seats. Suppose a certain city has 2 districts, A and B. The populations of the districts are given in the table. There are 100 police officers that are employed to patrol. These 2 districts apportion the officers using Hamilton's method. So this is the example. First, we notice that the total population is 100,000 and the number of officers is 100. So the divisor that you can see here is 1,000. So to find the quota here is to divide the district population by 1,000. The next step is to remove the decimal part in the quota for initial allocation of the quota. So district A receive 10 and district B receive 89. But notice that their sum is 99. And we have 100 officers, so we give the extra officers to the district that has a larger decimal to its quota. So comparing 0.45 to 0.55, because 0.55 is larger, so the last officer assigned to district B. So the final apportionment is 10 officers for district A and 90 officers for district B, giving us a total of 100 officers.